Hello everyone. This video is a required video for my B days. A days might end up watching it too, but on this day for at least the B days, you had a few optional videos that you can watch, and this one is not optional because we are going to go through and finish this lesson. So we were able to get through all of the bar graphs or bar charts part of the lesson. And what we need to go through and finish is the pie chart or the pie graph part of the lesson. So we're just going to jump right in and start on our relative frequency table. So there is one thing that I didn't get a chance to talk to you about in terms of a relative frequency table. What I would like for you to do on your table is to go through and add up the percents that you calculated. Now we know that these percents are supposed to add to 100% because that's how this works. Our percentages or our categories are based off of a whole, and a whole would be 100%. So I want you to go through, really do it. Don't just assume that they equal 100. Really legitimately go through and add up the percents that you calculated. You don't need to pause the video. I'm just going to wait. I'm going to give you like 30 seconds to do it. About 15 more seconds. 10. 5. 3, 2. Okay. I went through and added mine and got 102%. So why am I getting 102% when I know that these are supposed to be adding to 100%? This is called rounding error. So if you got something other than 100%, I want you to make sure that you write down and acknowledge that when you are converting fractions to decimals, because we're rounding to whole percents, sometimes we're going to end up with this thing called rounding error because of the way we round. So I ended up getting 102% because I rounded up a couple of numbers where the number that I used to round was 5. So one of the optional videos that you guys had was how to change fractions to decimals, and I went through to show you slowly how you put it in your calculator and how you round. So if you need a little bit of extra support with that, you're definitely going to want to go in or go back and watch that video. I think that it will be very helpful to some of you guys. So I'm going to pull up the paper that I used when I went through calculating decimals. So what happens, or what happened for me to have a percent bigger than 100, is these decimals right here. So remember, your cutoff is 5 or above, give it a shove. 4 or below, let it go. So 5 is the cutoff number. If you get a bunch of decimals where you have a 5 and that's what you're using to round up, you are probably going to get a percent here that is different than 100%. You're going to probably get a percent that is higher. So if you had to round up a bunch of your numbers, it is common for you to get a number bigger than 100. If you rounded a lot of numbers down, it is possible that you will get a percent less than 99. So here, on this example that I did in the other video, I had to round down a couple of times. So I'm going to quickly add up these percents and see what I get. So this one worked out. This one ended up being 100%. And then in that video, we did one more. And I already added them together. And on this one, we have 101%. I was able to talk to my A-Day class about this, and I had a couple of students in that class that had 98% instead of 100%. So the whole point of what I'm talking to you about now is for you to know that it is okay when you're making a relative frequency table or when you are converting fractions to decimals that you get something that's a little bit bigger or a little bit less than 100%. Remember, if you're having to round down, or sorry, you don't actually round down. If you're not rounding up, then you're probably getting or not probably, you could get a percent that is less than 100. If you're rounding up, you could get a percent that is more than 100. So if yours don't add to 100, it's okay. You are okay if you have 98 through 102%. If it's anything lower or higher than that, you're going to want to go through and verify that you actually rounded your percentages correctly and that you entered them into your calculator correctly. But if you end up somewhere between 98 and 102%, you're probably just dealing with rounding error and you don't have to fix that. You just you move forward with the problem as best you can and use the percents that you have. So I'm going to recap that one more time, and then we're going to move on to the pie charts. So when you change a fraction to a decimal, you are going to have to, in some cases, round that decimal to a whole percent. If you are rounding that decimal up, you may end up getting more than 100% when you add all of your categories. If there are ones, if you had a lot where you did not have to round up, you kept the percent that you had, you may end up getting a percent when you add your categories that is less than 100. In either case, it is okay as long as the percentage is between 98 and 102. So between the ones I've done, I haven't got any under 100, but I had 102 here. I had 101 and 100%. And then, like I said, I had a couple of students in 1A that ended up getting 98% or 99%. So just know that that is okay. Moving on to our pie charts side, this is what we are going to spend the majority of this video on. Now, obviously, my pie chart that we did in class looks a lot different than what we did together. For every stats class, we were able to get this far. We weren't able to start talking about the check for understanding, but we were able to make the pie chart or the pie graph. We went through this, how you break up your circle, pretty quickly. So if you need a little bit of extra support with that, if you want to go through it a little bit slower and get a little bit more information on how you break up a pie chart or make a pie chart, I have made a separate video for that, which is optional. I think it's only like 7 minutes. So if that's something that you want a little bit more information on, you'll want to go back and watch that video. So this is the pie chart that I made in that video. It's the same information. I just wanted the circle to be bigger so that it was clearer how I was breaking up the circle. So the biggest takeaways from pie charts are these 2 bullet points right here. So number 1, when you have a pie chart, you want to make sure that the categories make up a whole. The easiest way to check to see if your categories make up a whole is to add your percents. If your percents do not add to 100, that is an indication or a hint to you that you should not be using a pie chart because the categories you're seeing do not make up a whole. You're going to see examples of that in this video, so hopefully that's going to make more sense by the end of this video. So biggest takeaway, your categories need to make up a whole. The easiest way to check or get an indication whether they do is to see if the categories add to 100%. So the other thing that we did that is important is we identified, at least for this example, what the whole in this problem was. So these categories, these brands, make up all of the smartphones being sold in the United States. So the whole in this example, or the whole that these categories make up, is the US market share. That is all of the cell phones being sold in the United States. Okay, let's see if we can use those basic ideas to do number 1 and number 2 on our check for understanding. So number 1 says the table below shows results of the Statista Global Consumer Survey conducted in the United States in 2020. Respondents answered the question, what brand is your primarily used smartphone? Because some people might have two, one for work and one personal. There were 3,976 respondents that were aged 18 to 64 years old. So to make a pie chart, we need one additional piece of information, and this problem wants to know what it is. So I go over here and I say, okay, I'm going to check my table. I have 5 different brands. I have Apple, Samsung, LG, Motorola, and Google. But in my last problem, there was this brand Lenovo, and Lenovo isn't included in here. And I wonder if there are other brands that aren't included. Like my husband has a Google Fi phone. That's not included here. So maybe I should add up these percents and see what they equal, because it seems like I might be missing a category. So we're going to add them up. You should probably do that for yourself as well. You want to move toward doing some of these more basic tasks on your own instead of waiting for me to do it. So I'm going to wait a second just in case some of you guys are actually adding them. So these percentages only add to 93%. So maybe the missing 7% are other brands like Lenovo. That's what we had here. We had a category here that included other brands like Google Fi or Motorola or Google. Oh, duh. I guess Google would be Google Fi. Sorry about that. But we at least don't have Lenovo down here, and we don't have Motorola up here. So I'm thinking that what we're missing is a category that's like labeled as other and includes brands that are not the 5 listed here. And we know for sure that Lenovo is going to be one of them. So our response to this question is the category making up the missing 7%. The category making up the missing 7%. You could also say the brand or brands that make up the missing 7%. So I'm going to like highlight that here. This is the brand or brands. So maybe it was like 2% is Lenovo and 4% or 5% is another one. So it may not be a group that's labeled as other. It may be 2 other brands that have very small percentages. Either way, we're missing whatever makes up the 7% that we are not getting in the table. Then the last question for this one is, what whole do these categories make up? So up in this table, these brands, these categories made up all of the phones that were being sold in the United States. In this table, what is the whole? What do these categories, what whole do these categories make? Well, these categories aren't phones that are being sold. Like this brand isn't about phones being sold. This is about the brand that people use. But what people? All people? Did Statista send out a survey to every single person? No. So who is using these phones? The people using these phones are the 3,976 respondents to the survey. So what we're seeing in this table is the categories of phones that these 3,976 people used. So your whole in this case, so I'm going to say the whole, I'm going to write that in quotation marks. The whole is the 3,976 respondents. So I asked myself, what do these categories refer to? The categories refer to brands of smartphone. Okay, well, what about those smartphones? Well, these are the smartphones that are being used, but who is using them? The people that are using these phones in this table are the 3,976 people that responded to the survey. Okay, next question, number 2. Now, in this problem, letter E, the rest of the answer got cut off. So you can scribble out option E because you're missing the rest of the sentence. So number 2, the following pie chart summarizes the results of a survey given to airlines about the primary reason for flight delays. Which of the following statements is supported by the pie chart? So we have a pie here. The percents add up to 100. Let's see if you guys can determine what the whole is. What is the whole in this particular example? Pause this video if you need a second to think about it. Actually, everybody should probably pause to give yourself enough time to write it out. And I would very strongly urge you to try to figure out the whole on your own. Don't just keep watching and have me tell you. You're going to get the most from this if you try to figure it out. So pause, write it down, and then come back. Okay, hopefully you really paused and tried to figure out what the whole was in this case. So in our pie chart, we have the primary reason for flight delays. Well, which flights are being delayed? We only know about the flights of the airlines who responded. So this isn't every single flight ever. this is the flights that come from the airlines that responded to this survey. So what this means is that the whole in this case are the airlines that responded or participated in the survey. So I'm assuming that they sent a survey out to a bunch of different airlines and they said, what is the primary reason that your flights get delayed? And 70% of those airlines responded and said weather. So the whole is all of the airlines that responded or participated to or in the survey. Okay, so let's go through our options. Which of the following statements is supported by the pie chart? A, the reason given most frequently was runway closure. Definitely no. 8% of the time it was runway closure. B, more delays were caused by weather than all other reasons combined. So weather was 70%, which means that all of these other categories make up 30%. So B is true. There were more delays caused by weather than all other reasons combined. Weather was 70%, all other reasons combined was 30%. C, more delays were caused by runway closure than were caused by overbooking. No, 15% of the airlines that responded said the primary reason was overbooking, but only 8% of the airlines that responded listed primary reason as closure. And then D, overbooking and runway closure accounted for greater than 1/4 of the reasons. So greater than 1/4 would be greater than 25%. So greater than okay, well, overbooking was 15 and runway closure was 8. That equals 23%. So it did not account for more than 1/4 of the reasons for flight delays. Okay, so those are the first two problems on our check for understanding. The biggest takeaway from these problems is being able to identify what the whole is and understanding what the different sizes of the categories represent. So next up is question 3. And this guy is a challenge. So I'm thinking if I want to do this now or if I want to do it in another video. I think that you should go through and try number 3 and the rest of this. I'm not sure that you're going to struggle with number 4 or 15 or 31, but I do think 3 is a bit of a challenge. So try 3. If you're struggling, then just know that I will discuss it in the solutions video. And then you're going to want to try the rest, 4, 15, 31. Knowing that 3 and 31 will probably be the most challenging, and 4 and 15 should be okay. So I'm going to go over 3 in depth in the next video. So try as many of these as you can. So the second sheet, try as many of these problems as you can, and then we'll come back and I'll go through the solutions to these problems.